Well, welcome. I'm glad you're joining us today for a special presentation of Sandy Creek's Nature Center's Scary Oozy Slimy Day. I'm Dr. Maurice Snook. Some of you may have seen me come to your school and present my exciting chemistry shows. Hopefully I'll be able to get back and doing those soon. But today I have selected about 7 exciting scary, oozy, slimy experiments that I would like to present to you. These are in the field of chemistry. Now, chemistry is just one of the sciences. There's many different sciences. Maybe you can think, what is the science of the study of the stars and the planets? I think. If you thought astronomy, you were correct. How about the study of the science of weather? That's called meteorology. Think about the science of rocks and minerals. We call that geology. If you thought of that, you're correct. And how about plants and animals? That science is called biology. They do quite a lot of that here at Sandy Creek Nature Center. I like to think of chemistry as the main science. It's used in many of the other sciences. On this piece of paper right behind me, I can write the word chemistry just with my finger. Here we go. C-H-E-M-I-S-T-R-Y. Now this is special paper. It has thousands and thousands of tiny little ink balls on it. But the ink balls are covered in white, so you can't see the ink inside. I cannot crush the little balls of ink and let the ink out by scratching. Scratching won't do it. I have to run my fingernails over this paper fast, generating what's called friction heat. Now you see, I'm making lines on the paper. You're familiar with friction heat. Let's all rub our hands together fast. Oh boy, feel the heat. That's friction heat. Yes, friction heat. The friction heat is what releases the ink. Let me show you how much ink is actually on this paper. I have a hot plate right here. I'm going to just touch the paper to the hot plate. And look what happens. Wow. I didn't burn the paper. The heat from the hot plate melted all the little ink balls and released the ink. You may think you've never seen any kind of paper like this, but every time your mom brings home a ticket from, say, Kroger or Publix, this one's from Lowe's, with what I bought listed on it. Later today, ask your mother for a piece of paper like this, put it on a hard surface, and draw across it fast with your fingernails, and watch how the friction heat draws lines. It's much better to have the ink on the paper than to buy those expensive ink cartridges, because when those ink cartridges are empty, we throw them away, and that's polluting the environment. This is called thermal writing paper. It is writing with heat. See that? Writing with heat. Let's think of another way that we can help the environment. Plastics are a very bad problem out there in the environment. They are especially bad when they get into the oceans and just even on the road. Pollution, plastics. This I have here is a styrofoam cup. A chemist made this cup. But what do we do after we drink out of it? We throw it away. This will sit out there in the environment and pollute the environment, and some animals might even eat it thinking it's food. Rather than throw it away, I can take this liquid and squirt it on the cup and we'll see what happens to it. will see that it looks like it is dissolving, melting almost. It's not really dissolving, melting. It's like salt going into water. It dissolves. But if you evaporate the water, you get the salt back. If I would evaporate the liquid, I would get my plastic back. But as it is, it looks like an oozy marshmallow. I can use the liquid over and over again, and then take the plastic and make a new cup, add new chemicals, maybe make a new plastic. Find ways in which you can reuse the plastic that we're throwing away. I'm sure many of you, your mom has been buying things online, and when the package comes to your house, lots of times it has these styrofoam packing peanuts in it. These packing peanuts are thrown away, but they won't degrade and they pollute the environment. They float on water. See that? Water will not destroy them. But, take these out. If you have a package that has these kind of packing peanuts, these are made out of starch. And what is starch? Bread is mainly made out of starch. But these will biodegrade, go away, and not pollute the environment. Watch what happens when I put them in the water. They all of a sudden will dissolve. Look at that. They're dissolving and going away, not polluting the environment anymore. See that? Actually, starch makes a good glue. Flour is made mainly out of starch, and you can make a good glue with flour and water. But you see that? All dissolving and not going to pollute our environment. That's what we want to do with all our plastic. Make it biodegradable. I would like you to go around to your house today sometime and write down everything in your house that is made out of plastic. It's a good project. Plastic is a polymer. A polymer is many, many small molecules hooked together. Here I have a molecule and many molecules, and if we hook them together to make one long, long molecule, we have a polymer. Poly means many. Most of you are familiar with slime. Slime is a polymer. Here I have a long chain molecule. It's called glue. Your white glue, this is without the white, is a polymer. But when I add borax in here, which is soap, and stir it up, all of a sudden the long molecules hook together to make a bigger, longer molecule, which you know as slime, a polymer. Let's think of another way in which we can help the environment. Recycling cans. Recycling cans is very valuable. You can get money for it. And it saves a lot of money to make a new can. Costs less to recycle the can than to make a new can. Now it doesn't take long before my barrel is full of cans. And I have to go out there and stomp on them to get them smaller, get more in the barrel. I was thinking, what could I do to crush this can easier? I have in this can water, and it's boiling. And I'm not sure if you can see the steam coming out of it. It's very difficult on the video, but we have steam coming out of that can. So it's boiling away. I am going to put some ice in this bowl of water. Let me get some ice out of this bucket here. Put it in this bowl. Get it real cold. Nice cold water. And we're going to now turn this can upside down into the ice cold water. So pay attention and watch close as to what happens. Here we go. 1, 2, 3. Wow, look what happened to the can. Crushed it, didn't it? Imploded. What happened? As soon as I took the can off of the hot plate, turned it upside down into the ice cold water, the steam that was in the can condensed back into just a couple of drops of water, because steam occupies a much larger volume than the water it comes from. And that left no air in the can. We have a special name for no air. Maybe you can think about what it might be. It's called a vacuum. And when I formed a vacuum in here, this can could not stand air pushing down on top of it, and it crushed it. Air does push down on top of you, but you don't feel it because the air inside of you is the same as outside. But here I have a bottle, and you can do this too at home. Take a soda bottle or a water bottle, plastic. It has the same pressure of air inside as outside. But when I create a vacuum by sucking on it, air pressure was pushing down on that bottle, trying to get in to equalize the pressure. And when I released it, the air flowed in to equalize the pressure. You could do that when you go like this. Your diaphragm muscle pulls down, sucking the air out of your body, out of your mouth, sorry. And air pressure is pushing your cheeks in. You're not doing that with cheek muscles. Air pressure is pushing your cheeks in, and then when you let go, you feel the air rush in. Air pressure. Here, I have a tube filled with air. See that? I'm going to increase the pressure of the air in there by squeezing it. I can't do it by doing like this, but I can do it. A little bit of water for lubrication, and we're going to squeeze this thing, and we're going to see what happens. And the camera's watching, and here we go. Wow! It flew way across the room. Air pressure. You are hearing me right now because my voice, air pressure waves are going from my mouth to the microphone, being converted to electricity, sent over the wires into your computer, and it is remade into air pressure waves by your speaker in your computer. Air pressure waves are hitting your ears, drums. Believe it or not, your eardrums are vibrating. They're converting back into electricity, which is carried up to your brain and you interpret as sound. Now, not only does air pressure waves go through the air, but pressure waves go through solids, like this table. What I would like you to do is put your head on the table with your ear on it, and way over here, the table with your fist. You will hear the thump, but you will feel the vibration of the pressure waves going through the table. That's how earthquakes are very destructive. Rocks slip by one another, and the pressure waves going out vibrate the Earth's surface and rock buildings and have danger. That's real scary, isn't it? Yes, it is. There's pressure waves out in the air. We call those high pressure and low pressure areas. Low pressure means storms like the hurricane occurring right now. High pressure is fair weather. Sometimes those pressure can cause tornadoes. Tornadoes have very low pressure, and it causes the air to spin around. We're going to show you an example. Here I have two, we call these flasks. I have a magnet in here, and I have a magnet inside on the motor, and you know how two magnets will turn one another? So the magnet down there is turning this one. But just to show you how we can make a tornado by chemistry, watch the tornado form. Oh, isn't that pretty? Look at the beautiful blue tornado. And over here, I can make a pink one. I have different chemicals in here which change color depending on the chemical I'm now adding. That's the safe way to have a tornado. No scary ones, no. All right, you like scary things, maybe? How about horror movies, scary horror movies? I want to show you how they might use chemistry in the movies. I put this liquid on my hand. You really can't see it there, but if I dip this spatula, it is like a butter knife. It won't cut anything, see that? But if I dip it into this solution and pull it across my hand, blood comes out. Oh, wow, wow, scary, scary, oozy blood. See that? Scary, oozy blood. Now, ooh, it's really running everywhere. But as a chemist, I don't have to worry about that blood. I can make it disappear with this special solution. I'm going to put some on this cloth. And watch how the blood disappears by magic. Just like magic. Yes, just like magic. No blood anymore. Got to do where it went everywhere. No blood. So that's how they might use chemistry in the movies to make you scared. Okay, for our final experiments today, we would like to do some oozy things. Most of you are familiar with making the bicarbonate, baking soda, and vinegar volcanoes, right? That's like oozy. I'm going to put a little bit of bicarbonate in here. And if we now add the vinegar, the two chemicals will react and form a lot of bubbles. See the bubbles? We're making carbon dioxide. That is the same gas that is in soda pop. We're breathing it out. Carbon dioxide has filled up this flask. It's heavier than air. And I want to show you that what it'll do, if I light this little piece of wood, the carbon dioxide will snuff it out. See that? Because there's no air in there, no oxygen. Alrighty. I want to show you a different way to do it. You can do this at home this way. Is that, again, we put the bicarbonate, and what you need to do is get a tall glass at home and put the bicarbonate in there, swirl it up to dissolve it. But this time, add a little bit of soap, liquid dishwashing soap. Just a little bit. Doesn't take much, just a little bit. Now when we add the vinegar, the bubbles do not break immediately, but they form an oozy thing. See that? Up and over it goes. Oozy. Again, we're making carbon dioxide bubbles, but the soap prevents them from bursting and forms your foam. For our last experiment today, we are going to make the elephant's toothpaste. Okay, now we're going to make the elephant's toothpaste. Wow. This time, instead of making carbon dioxide bubbles, we actually made oxygen bubbles. And I'm going to show you oxygen bubbles are different than carbon dioxide. I blow out the flame, it relights. See that? Because oxygen supports combustion 100% much more efficiently than what's in the air. And that is why right now with these COVID-19 pandemic, when people are in the hospital, the COVID-19 hurts their lungs, scars the tissues in their lungs, so it doesn't absorb oxygen as well. And that's why many patients are given 100% pure oxygen if they have to go into the hospital with the virus. I hope you enjoyed today's Scary Oozy Slimy Day at Sandy Creek Nature Center, and I hope you'll come visit the Nature Center sometime in the near future. Bye.